Actually, good afternoon. It's still 3:55. As you know, Siri announced, my name is Ashrith, and I work as a security scientist at H2O. My area of specialization is detecting, anomalous behavior. So that kind of comes off right off where Leland left us, which is, detecting outliers. So I hope you guys got enough information from that talk. So today's talk is actually intercepting dirty money, using machine learning. So the idea here is that it'll be a fairly high-level talk, which will kind of tell us what are the ways to look at, your financial transactions. What are the ways to look at how your money flows? Much before that, I think this is something that's really close to me. Is why do you even, why does it even matter? Why do you even have to do something like this? So, and please feel free to ask me any questions, on the way. You're more than welcome to stop me and ask me any questions that you feel like it. So the why, the big question, which I think we always ponder, is the why. Why do we do these kind of things? So, dirty money, as we all know, is money that's obtained through illegal means, through immoral means, or unlawfully, which is actually one of the most important things for a system, because it means that we're losing out on taxes, we're losing out on something that can be invested back into the society, which can be improve the value of human society itself, for that matter. And how is it usually done? Usually the idea is you have human trafficking, drugs, or malware, or some forms of terrorism. So right now you have a lot of cyber mercenaries. I don't know how many of you guys have heard of it. The idea is that you get paid to hack into different accounts, different countries, destroy their electrical system, the sewage system, the water system, the transportation system, and that is kind of a big issue right now. But they all get paid. It's all illegal money. So now, how is this money kind of used? Set up puppet governments, to set up armies that are not necessarily, listening to anyone, purely just the money, and eventually, retard all the kinds of progress that you could see in terms of governance, governments, societies, and such. So how does this actually happen? So how does money laundering happen? Anyone have a fair clue? Anyone? I think a lot of people here are probably from the banking industry, so I guess you should know, but if not, if anyone wants to say it, you're more than happy to raise your hands. So general approach, very simple. You collect the dirty money, you place it into the system, and then it goes around through some kind of a magic. This is where the big magic is. And then it eventually comes out as something that looks like white money, for that matter. So let me explain this to you a bit. You have on the street, on the system, mules who actually connect money. It's usually in the form of cash. It's hardly electronic. Sometimes it is electronic. I mean, now with the onset of bitcoins, a lot of money is actually coming through bitcoins as well. And then it gets placed through banks. How many of you guys know what smurfing is? Okay, so the general idea in smurfing is I have 10 friends, and I peddle drugs. No, I don't. I'm just saying it. And what happens is all these 10 friends of mine are given some amount of money every day, and they go deposit this money into their accounts. Then after they deposit that money into their accounts, which actually happens in the placement, then what happens is a part of the system is where they move around the money. They could move it between themselves. They could move it to an external party, spouses, children's accounts. Usually a lot of kids' accounts are misused for this purpose. The money is moved around, and then eventually it comes back to me, because that is how I eventually get the money. And then what I do is I take that money out of the system in the way that it goes as an offshore, money is transmitted for some offshore account. It's invested to interesting things. And then it comes back into the country, and then I buy things with it as if it's like clean money. So that's usually how the system works. That's usually how money laundering works. 3 fundamental layers where you're placing the money in the system, and then you're layering it. The idea of layering is to obfuscate the source of the money. There are lots of banks, organizations who are actually trying to find out, where is your money coming from? And layering that's the most important thing. And this, of course, is the most fun part, where you get to start buying watches and cars and whatnot. So as a financial organization, what are the different points or what are the different aspects that you're looking at? No financial organization gets to look at the entire picture at any given point in time. Hardly. This does not mean that I have a fair idea of how the system works. It's merely because I have worked with a lot of organizations that I have understood how to look at these things. So, which is one of the issues that actually a lot of financial organizations go through. So sometimes the financial organizations intercept at the first step. This is actually happening in countries, where there are a lot less cash transactions that are currently existing. For example, in Europe, where they hardly expect any more cash transactions to happen, anytime cash is actually deposited into the system, it is alerted. And above a certain threshold, it is alerted further, and then it is escalated. That's not the case in North America because a lot of transactions happen in cash. That's not the case in Asia yet because a lot of transactions still happen in cash. So this could be one point of interception. The other point of interception is where you're moving money between accounts, between banks, or between systems. And the way banks currently intercept this aspect is where they detect that similar sums, similar volumes, transactions on the same day, transactions with a certain period of time actually keep going around the system. And this actually takes a lot of time. The reason being you cannot detect a loop or loop of cash for that matter in a small period of time. You have to look through this loop for a longer period of time to say, oh, these are the 4 people who are actually moving the money around. And it doesn't necessarily go out of them. So this actually takes time for banks to explore and then set up rules. Something that I've probably skipped right now is currently most of the financial organizations tend to have rule-based systems and some amount of intelligence across these rule-based systems to detect these steps. Now this aspect is one of the aspects where a lot of them miss the ball. And it only happens when they see a ridiculously crazy purchase. And what I've seen that the usual code of conduct that happens in this stage is they call up the customer and they're really nice to the customer and they say, hey, you just bought a new car. Where did this money come from? And he says, oh, my dead grandma, and that's about it. Which is really surprising because this also should be a place of alert, a place where you should get alerted. So these are 3 different points of interception. Depending on how good your financial organization is actually equipped to detect the flow of money or detect entities in each of these systems, you'll be able to figure out, you'll be able to connect all the dots and figure out if the money is moving around. Now, as I said earlier, most of the times that doesn't happen. We are always at a loss when we are in the placement stage to figure out where the money is moving because probably it's moving between banks or here it's moving offshore, which actually is one of the biggest problems I think financial organizations would have. I think some of the big organizations would say that the moment the money leaves the shores, it's really difficult for them to track. Or for that matter, it gets transferred to someone else and then someone else buys something out of it. So in each of these points, it's independently really difficult to detect these things, but as a system, it is really easy for one to detect it. But for that, you need to actually train your data to be able to figure this out. So the way you could break this out is data at rest, or interception at rest or interception motion, where it's at an entity level or actually being transferred to other people. Any questions up till now? Please feel free to stop me anywhere that you think is important for you. So now, how do we involve machine learning into the whole process? So it wasn't easy for us to get into the zone, because what I had started with was I had actually started off with a lot of anomalous behavior in the field of cybersecurity and then financial fraud. So this is actually much further from fraud. But it does not mean that you can't use similar anomalous behavioral techniques, similar profilings, and different gradients of building features onto this approach as well. So one of the places we started with is we said, let's make the problem really simple. Let's try and identify people who seem to be suspicious people who seem to be suspicious in terms of what they're doing, regardless of whom they're interacting with, regardless of what kind of activity that they're actually doing. Purely attributes associated for a person. For example, if you look at this, can you guys read the text, by the way? Is it easy? Okay, great. So what you see here is that we are building a profile around a person where we try to figure out if the person is primarily operating in cash or using credit cards or any other kind of monetary instrument. We devise a geographical identity for them, a social identity. The social identity can actually speak about, you could also bring about associations of what kind of spending these guys do. Maybe a lot of grocery purchase, maybe a lot of eating out. So these could be like a secondary social identity that you could bring about as well. Geographical identity, things like how many times has this person changed their location? Do they keep changing their houses? Do they keep changing countries? Do they keep changing their cities for that matter? Ingress and egress, how much of money actually flows into their account and how much of money actually goes out of their account? Interactions. How many people do they primarily interact with on a monthly basis, on a yearly basis, on a long-term basis? How many of them are actually high volumes? How many of them are actually low volumes? What is the kind of transaction? Does this person have, does this person usually send only to a certain kind of people? Does this person receive only from a usual kind of people? And operational window, how long does a good sum of money actually stay in your account? The moment you get money, do you have a tendency to actually pay it out? For example, a lot of us who depend on our pays on the first of the month, the moment we get the money in our account, we tend to pay out our credit card bills. That is actually common behavior. But sometimes when you get money that is illegal, and you are expected to actually hold it in your account so that it doesn't seem suspicious, then there is usually a period of time that they'll hold it. So this operational window actually figures out, what is the amount of time that they tend to hold in their account. And volumes, what is the amount of money that actually flows through these accounts? It could be ingress, egress, however you look at it. And volume rate, what is the rate at which money actually flows in, per day, per hour, per week, and things like that. Past triggers is actually something that we tap into, which is an existing system in the banks. Banks tend to have this information, where they have extremely alert investigators who have actually identified that an account is dangerous, is doing something suspicious, malicious, or there are systems that are actually triggering this out. So we bring in features all around that I've described on the slide of a person and put it actually into a model. Now, mind you, this is purely predicting a person's behavior. This is not exactly tagging the person itself. If you were to remove the identity of the person itself, you would still have attribute for person X, and that's how we kind of profile a person. Now, it so usually happens that if you have suspicious people, and mind you, this is suspicion with a good amount of probability. This is not a kind of suspicion where you say, I'm wearing a hoodie, so that means it's suspicious. No, it's not. It doesn't work on those kind of things. It's the idea that if a person is suspicious, it leads to some kind of a suspicious interaction. If I tend to deal with drugs, that means that I tend to work with people who move this money for me. And which is why what we do is The next step in terms of how our model was emerging is we started building attributes for the interactions. So what we looked at is, what is the relative age of interaction? What is the kind of loyalty that does a customer have with the banks? Is this person, a long-term associate? Is this person a short-term associate? Now, mind you, there's a caveat in the loyalty. So what happens is it's never truly reliable. If someone has got an account for 50 years, that does not mean that this person is never going to commit a crime. Because there have been situations where people have actually been forced to commit crimes using their financial accounts. Now, there is also another issue in terms of the age and the loyalty of account, which is actually related. I'm not sure how many of them might be aware of it. Anyone want to take a guess? There is actually an issue with the age and the loyalty of different accounts. That is one of the common problems that we tend to see in the data. Anyone want to take a guess about what that is? So, okay, let me tell it. Maybe it's too abstract. So dead people tend to come back, which is like super weird. Like people who've been dead, their accounts get revived because those accounts never got closed, and they start showing interesting activities because those accounts were never closed. Now, that changes your loyalty profile. That changes the age, and that kind of screws up your entire algorithm. So you got to be aware of a lot of these things that come along with your data. As data scientists, we all believe that the data is one of the most important things in our system. But if the integrity of the data itself or the profile that we're building itself is lost, then we have a big issue. So you got to be really careful when you're bringing in these kind of features. Then the other thing that we also look about in terms of interaction is the periodicity of interaction, as I was talking earlier. The seasonality of interaction. Do I only move money to a certain place before April 15th because I want to avoid taxes? Is that a behavior that I have? System interactions. How many people do I interact with? Is it the same people? Is it different people? Do I, as I said earlier, do I move different volumes of money across different people? So this volume is kind of different from the personal profile that I'm actually talking about. This is actually a system volume. So what we look at is we look at people with high density of interactions, and we actually create them around as a system. And we say how much of money is actually being moved out of the system or into the system. What this tells us is that if all the people in a network are suspicious, or if, let's say, a good percentage of people in a network are suspicious, then with the system volume, we'll be able to identify how much of money is actually dirty or how much of money is actually legitimate. So that's a fairly good way of approaching when you assume that the interactions that actually happen is across a system. Then we also look at interaction rates. Now, do you actually move money, with your spouse, with your partner at a frequently high, at a pretty frequent rate? Do you move it across your friends? These are really important things. So this is purely building a profile of the interactions. And mind you, this attributes that we built is actually based off the emergence that we had from this one, where we said, okay, let's build a profile of a person, then let's build a profile of an interaction. So it's kind of an emergent process that we're actually going through. Now, so the next step that actually leads to is suspicious interaction actually leads to suspicious network paths, or planes for that matter. Now, you might be thinking, why are we going in the direction of a suspicious path or a suspicious plane for that matter? The reason is because if you look at the initial diagram that we had, and if you can pardon me for a second, I'd like to go back to this. What we're trying to do is get an entire view of the system. We're trying to see how the money is coming in, how the money is being, boiled, broiled, whatever it is, layered. And then how is it exiting the system looking clean? Now, this is one of the reasons we actually need to figure out where the money is going, in which direction is the money is going. It's, for example, it's as similar as figuring out, which way the river flows. The river flows towards, a place where the slope is much lower than where it started off. So which is why that's, you know, that's kind of the idea behind this. And what we do here is, when we're looking at the entire network, we're looking at how is the network moving. This is actually a primary question. Is the network convergent or is it divergent? And mind you, if the money is actually moving to one person, for example, you know, this person where the money is moving in, the network is super convergent. That means that, you know, this person tends to have the final authority of all the money that's moving in, or this person is one of the final layers of where the money is moving in. Now, what happens is, the guys who do this, mind you, they're amazingly smart. So they actually make the network divergent. So when we actually plot this, when we actually figure out how the network is moving, they'll randomly move money around. And the amounts will not even be, you know, understandable. It's large sums, small sums, you know, all across the spectrum. So you got to be sure of that as well, that the money is actually not taking a divergent part, but it's actually converging. So if there is a divergent part, you must be able to train your algorithm to converge to a point and say, look, forget that, just look at the convergence. We also look at how the network actually has its periodicity. You know, how much of money gets moved through the network. Is it large sums? Is it aiding another network? Or is the money actually ending in this network? That is some of the things. In terms of arrival times, one person might have a lot of outliers in terms of, you know, their seasonality. I might get a money from one of my mules, you know, this Sunday, or I might get money from my mule the next Sunday or the next Saturday. So when you put that into an algorithm, the issue is it's not necessarily tracking the behavior really well. But when I'm tracking a network, it is fairly accurate in terms of the periodicity. Here, I'm looking at a good amount of time, you know, where it says, okay, this network tends to move forward in like 3 months, in 1 month, or in 15 days, which is actually super interesting from the point of, you know, analysis for us. Now, we also look at recent behavioral changes to see whether a network is actually changing in its volume. Is it changing in the movement of the money? The reason being, the recent changes in behavior actually points back to any of the people in the network being identified as suspicious, which is actually the most important thing. One of the most important things is also to figure out the lock level. The lock level is a measure of how much money actually is retained in the system. So this tells us how far into the network are we. If we are in very, you know, in the very initial layers of the network, then the size of this lock level will be really small. That means that these layers of the network will actually hold very little money compared to the later layers of the network. So depending on the lock level, we figure out, you know, how deep are we into the network. If there is a good amount, like let's say 90% of the money that actually comes in stays in the network, that means we are converging close to, you know, people who could be actually running this whole system or syndicate or whatever it is. We also look at pass-through to origins and ratios. So some of the pass-throughs to origin ratios is, so most of these guys are actually, most of these people rather, sorry. Most of these people actually are moving money of their own and also have their own accounts, you know, which gets money, their payday or whatever. So based off that, we figure out how much of the money that they're actually moving around is, how much of their account is being utilized for purely moving money, you know, to wash it around, or, you know, to actually be a secondary activity across their accounts. And we also look at what the egress point is, you know, to see if the network is actually converging towards an endpoint or an end customer or things like that. So the way we look at dirty money is, you know, it's a level of emergence, I would say. Probably like every time we improve from a person to an interaction to a network, it's like an order of magnitude that we go up into the model. And all these things that I actually talk about, these are actually features that go into a machine learning model. Each of these actually has got a parameter. It goes into a model, helps us detect what the situation is. And the way we break down the model is we build models for individuals, we build models for interactions, we build models for networks. And the final model that we have is actually a weighted average across all these interactions depending on how well the model is. And so coming back to the techniques, of course, this is a machine learning talk, so I have to say this. How do we do this? So if you have the attributes, and if they're statistically good, but you do not know the outcome, then of course, unsupervised is the best approach to go. But have some decent approach of partitioning this using probabilities, and then have a human in the chain. This is super valid. I mean, all the investigators that you have in your system are useful when you have to verify these models for you. If the attributes are solid, and if you know the outcome, meaning if you have the labels, then go ahead with a supervised system, with a human verification system as well associated with it. And mind you, either of these things, you could build it as an ensemble, or you could build it as one model, depending on how you see your problem, how big the problem is. If your things are not statistically solid, then please talk to us. Just saying. So yeah, that's basically the end of my talk. And if anyone has any questions. Maybe not? Great, thank you. Thanks, guys.